Your brain is about to tell you that what you're seeing is impossible. But I promise you, science says otherwise. These next experiments look like mistakes, glitches in the matrix, or straight-up illusions. But every single one is real, and once you understand the simple physics behind them, your mind is going to flip. We're about to dive into some of the most counterintuitive, reality-bending demonstrations you've ever seen. Let's start with something that seems to break the most fundamental law of nature, gravity. Look at this double cone. I place it at the bottom of this ramp, and instead of staying put, it starts to roll uphill. How is this even possible? It looks like it's defying gravity, rolling from a lower point to a higher one. Is it a trick? Is there a hidden motor? Nope. The secret isn't in the cone, but in the ramp. The rails of the ramp are not parallel. They get wider as they go up. As the double cone rolls uphill, its widest part rests on the narrowest part of the ramp, and as it moves, the narrower parts of the cone rest on the wider parts of the ramp. This means the cone's center of mass, its balancing point, is actually moving downwards the entire time, even though the ends of the cone are moving upwards along the rails. It's a brilliant illusion where gravity is still winning, but our eyes are completely fooled by the shape of the objects. It's not rolling uphill, it's falling downhill in the cleverest way imaginable. Okay, next up, we all know how water behaves, right? It flows, it splashes, it spills, but watch this. I have a string tied between two cups. I start pouring water onto the string at one end, and instead of just dripping off, the water clings to the string and travels all the way across to the other cup. It's like a tiny, liquid tightrope walker. This isn't a special string or magic water. This is a beautiful demonstration of two properties, cohesion and adhesion. Cohesion is the force that makes water molecules stick to each other, forming droplets. Adhesion is the force that makes water molecules stick to other surfaces, like this string. In this case, the adhesive force between the water and the string is strong enough to guide the flow, and the cohesive force keeps the water stream together, preventing it from breaking apart and falling. It's the same principle that helps plants pull water up from their roots to their leaves, a process called capillary action. So the next time you see water, remember it's not just a simple liquid. It's a sticky, clingy substance that can perform amazing feats. Now, let's move from water to something that looks like it's from another planet. This is ferrofluid. It's a black, oily liquid, but it has a secret. It's filled with nano-sized magnetic particles. In its normal state, it just looks like a puddle of ink. But watch what happens when I bring a magnet close to it. The fluid springs to life. It forms sharp, intricate spikes that dance and shift, following the magnetic field lines. It looks like a living creature, a sci-fi symbiote reacting to an unseen force. The spikes form because the magnetic particles in the fluid are trying to align themselves with the magnetic field. They clump together along the field lines, and the surface tension of the liquid pulls them into these incredible pointed shapes. The stronger the magnet, the more dramatic the spikes. We can make it crawl, morph, and create stunning sculptures purely with magnetism. This isn't just a cool visual. Ferrofluid has real-world applications in things like loudspeakers, computer hard drives, and even as a coolant in high-tech equipment. It's a perfect blend of fluid dynamics and magnetism, creating a substance that truly feels alive. Alright, for our next mind bender, let's head to the kitchen. I have two eggs here, one is raw and one is hard-boiled. They look identical, but they behave in completely different ways. I'll spin both of them. See how the hard-boiled egg spins quickly and smoothly, like a perfect top. Now, watch the raw egg. It wobbles, it's unstable, and it stops spinning almost immediately. But here's where it gets weird. If I spin the hard-boiled egg, then briefly touch it to stop it, it stays stopped. But if I do the same thing to the spinning raw egg, stop it for just a second, and let go, it starts spinning again, all by itself. It's like a ghost is giving it another push. So what's happening? It's all about inertia and what's inside. The hard-boiled egg is solid, so when you spin the shell, you spin the entire egg. When you stop the shell, the whole thing stops. The raw egg, however, has liquid inside. When you spin the shell, the liquid yolk and white inside start swirling around. When you touch the shell to stop it, you only stop the shell. The liquid inside is still churning and spinning due to its angular momentum. When you let go of the shell, the friction from the still spinning liquid inside drags the shell along with it, causing the egg to start spinning again. It's a simple, brilliant demonstration of rotational physics happening right inside an eggshell. Finally, we have an experiment that looks like a glitch in a video game. I have a long chain of beads in this beaker. I'm going to lift one end and drop it over the side. You'd expect it to just fall, right? But watch. As the chain picks up speed, something incredible happens. The chain leaving the beaker leaps up into the air, forming a beautiful, self-sustaining arch before it falls. It looks like it's floating, defying gravity for a moment. This is the famous chain fountain illusion. For a long time, physicists debated what was causing this. The common explanation was momentum. As each bead is pulled over the edge of the beaker, it has to be lifted up first, and this upward push creates the arch. Think of it like a series of tiny pushes. Each link in the chain gets a kick upwards from the beaker's rim as it's whipped over the edge. This upward kick is strong enough to propel the chain high into the air, creating the illusion of a floating fountain. When you see it in slow motion, it's even more mesmerizing. It's a perfect example of how simple forces, when combined in the right way, can produce a result that seems utterly impossible. From cones that roll uphill to chains that float in the air, we've seen how the laws of physics can create outcomes that challenge our intuition. These aren't tricks, they're just reality showing us how much more there is to understand. Science isn't about memorizing rules, it's about being curious enough to ask why when you see something that doesn't make sense. If even one of these surprised you, imagine what else physics is hiding. Comment below and let me know which one of these experiments completely broke your brain. I'd love to hear your thoughts. And if you enjoy seeing reality get twisted, make sure you subscribe and hit that notification bell for more reality-defying science. Thanks for watching.